Alrighty, y'all. Today we're taking a look at homework 4, question 7. And for this one, we're trying to find the radius of the curvature of the proton that's moving within a magnetic field, right? So we have the mass of the proton, the charge, the speed, all this jazz, right? So we know that it's asking for the radius of the curvature. So that's a big ding, ding, ding red flag that we're going to be that it's moving in circular motion, right? So when we're doing that, our acceleration in the direction of the radius of our circle is v squared over r, right? That means that and then if we do mass times acceleration, mv squared over r is going to be our net force, right? And we get to set this equal to, because our force that's acting on it is our force from the magnetic field, right? So what we do, that's our q v cross b, right? Right, so we're given our velocity in a direction, right? So we can do our cross product, or we can simplify this, because by definition our cross product is q v, the magnitudes of each of these vectors, right? Because these are vectors. These are just the magnitudes of them, times the sine of the angle between them, right? Because we have b going in the j hat direction and v going in the I hat direction. By definition, since these are our like regular axes, you have like I, j, and k, or however you want to mess with them. We are looking at I and j. Those are a 90-degree angle. Sine of 90 is just 1, right? So we can set mv squared over r equals qvb times 1, right? So we can divide both sides by v to get rid of that, just to simplify our equation a little bit. So mv over r equals qb, right? You can solve this for r and plug in our numbers, but I'm just going to start plugging in numbers right now. Right, so I can multiply both sides by r, get that to move over here, divide both sides by qb, and we get that r equals mv over qb, right? And we're given that our mass of the proton is going to be 1.67 times, what was it, 10 to the negative 27. And again, we're keeping that in kilograms because that's our base unit. Our velocity, given in meters per second, is going to be 0.5 times 3 times 10 to the negative 8. Right, because that's given here that it's 0.5 times the speed of light. And then our magnitude of our B vector, our magnetic field, is 1 Tesla. So that's divided by, oop, I forgot Q. Our charge, 1.6 times 10 to the negative 19. And again, 1 Tesla. And I can center this on the bottom a little bit better, but that is what's going to give us our R. And since we have R we've kept everything in base units, this is going to give us R in meters, if you evaluate all that out. All right, well, I hope you found this video just a little bit helpful. Let me know if you have any more questions about this or anything else that you want me to try to explain, and I will do my best to explain it because I guess Sydney explains stuff.